Okay, so we're going to talk about deductive reasoning, the laws of logic. Okay. The goal is to combine true statements to arrive at a specific conclusion. This is known as deductive reasoning. We have conditional statements, P implies Q, and we have simple statements, just P. First, true statement. If I win the race, then I get a gold medal. Second true statement. I win the race. Conclusion, I get a gold medal. What conclusion can you draw given the following true statements? If I eat a spaghetti jazz, then I order lasagna. I am eating a spaghetti jazz. Conclusion, I order lasagna. If we let P be I eat a spaghetti jazz and we let Q be I order lasagna, then symbolically we can represent this argument as P implies Q and P, therefore Q. This line of reasoning is known as the law of detachment or modus ponens. That's the Latin phrase for this type of thinking. Given a true conditional, if the hypothesis is true, then the conclusion is true. So create your own argument. Okay. Invalid argument. If I win the spelling bee, then I go out for ice cream. I went out for ice cream. Can I conclude that I won the spelling bee? No, this is not the law of detachment. If my conditional and my conclusion are true, recall there is the possibility the hypothesis is false. There could be another reason why I went out for ice cream, and maybe I lost the spelling bee and my parents took me out because they felt bad for me. Chain rule. The next property is the law of syllogism, aka chain rule. Let's move my face out of the way. There we go. In this case, we combine two true conditionals to conclude that the hypothesis of the first statement implies the conclusion of the second. Symbolically, it is written as P implies Q, Q implies R, therefore P implies R. Here are two examples. If I go to sleep early, then I get a good night's sleep. If I get a good night's sleep, then I am not cranky in the morning. Therefore, we can conclude if I go to sleep early, then I am not cranky in the morning. Another example, if 2x plus 7 equals 15, then 2x equals 8. And if 2x equals 8, then x equals 4. Therefore, I can conclude that if 2x plus 7 equals 15, then x equals 4. Create your own example. Combining laws in an argument. First statement, if I win, then I go to Unimart. Second statement, if I go to Unimart, then I buy ice cream. Third statement, I won. What can we conclude? Well, I want to prove that I bought ice cream. We want to prove using the laws of reasoning. First, we're going to symbolize the statements to make it easier. Let W be I win, G, I go to Unimart, B, I buy ice cream. And we rewrite the statements as W arrow G, G arrow B, and W. We can use the chain rule to combine statements 1 and 2 to get statement 4. So W implies G and G implies B, therefore W implies B. Next, we can use the law of detachment to combine statements 3 and 4 to get statement 5. W implies B. We also know that I won, therefore we've proved that I bought ice cream. Try it yourself. What can you conclude from the following? If you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. Aisa lives in Accra. So let's see. I know that AC implies GH, or living in Accra implies Ghana, and I know if Ghana implies living in Africa. Therefore, from the chain rule, I know that living in Accra implies that I live in Africa. Also, I know because I proved that because I live in Accra, I live in Africa, and I know that Aisa lives in Accra, therefore Aisa lives in Africa. Law of detachment or modus ponens. Here's some more laws of logic. You might use them, you might not use them, but I just want to talk about it. The first one is the law of the contrapositive. If P implies Q is true, then not Q implies not P is also true. And this is known as the law of the contrapositive. And our example is, if it is 40 degrees, then it is hot. Well, we can conclude that if it's not hot, then it's not 40 degrees. Another law is called Modus Tollens. This is interesting. If I have a true conditional, but my conclusion is false, then I can conclude that my hypothesis is false. For example, once again, what I just said, the conditional is true and the conclusion is false, then the hypothesis needs to be false. So if it is August, then it is summer. Also, it is not summer. What can we conclude? Then it's not August. That makes sense. Think about that. Once again, if it is August, then it is summer. That is true. But it's also true right now, it's not summer. Therefore, you can conclude it's not August.